Well, hello, everybody. Give a few more minutes for more people to join up. For the most part, I was hoping to use this time more from feedback from section members, any things that you would like to see out of the section, ways that we could help support you, ideas about projects, content that may be valuable to individuals, that kind of thing. Just really informal discussion and we'll take it as long as we take it.
Well, hey, Rich, since everybody's being shy, this is Bob Buckheim. I wonder if you could offer a few sage thoughts on projects, photometric projects that AAVSO observers can make a contribution to. Open questions, for example, regarding these stars.
You specifically mentioned photometric. That's one I struggle with on LPVs. I see LPVs as very good visual targets and where really visual observers can make the most impact. When you look at photometric stuff, and the reason I say that, and I know we have some actual scientists on board here that can probably tell me I'm wrong, like Leanne can pipe in or something like that, but to be real valuable, you need really long timeframes. We're talking decades to really to notice anything with a lot of these stars. And if you're willing to commit to that with a consistent photometric program, by all means, go for it. But really, there's nothing to compare it back to, because like things like Myra stars, we see changes on the orders of 80. I mean, we're barely seeing some changes, but we have visual data that's 100 years old that we can observe some slight changes in. And you're not gonna have that history. I mean, I guess at some point you have to start it. Oh, Leanne's gonna save me from here. You're muted, Leanne. You're still muted.
The video. How do I do the settings so we can see?
Anyway, I was going to say everything you said is right, but there are some opportunities in multi-wavelength photometry. And one of the places this has been extremely useful in the last few years, even just a 3-4 year cycle, was when our Aquarii started down into its eclipse. And AVSO observers started getting us observations in a range of different bands. And that gives enormous clues as to what's going on during this once every 44 years event. And our Aquarii is special. It does something weird every 44 years, and we knew it was coming. But a lot of the LPVs do odd things. For example, there's a number of stars that seem to switch mode from fundamental to overtone and back. And multicolor photometry over the course of such mode switches can give us additional data to understand what's actually happening in the star. So there are opportunities. For the most part, if you take a well-behaved Myra that's been well-behaved for 300 years, you will need a fairly long baseline to get, long-term data. And but even there, it's useful to have a few cycles with multi-wavelength coverage so that you have you can fit models with more constraints.
Well, let me follow up on, because our Aquarii is definitely a unique system, and probably not typical of most Myras that an AVSO observer might be going out there. So what clues could we extract from, say I just go to a well-behaved Myra, I do BVR and I data for a couple cycles, would that be something relevant? Because I know from my own stuff, my CCD observations never get used. My visual observations get used all the time. And Margarita wants to say something too.
Yeah. Margarita.
Take a look at the latest light curve of Myra. The
Myra
product,
specifically. Okay.
yeah, the well-behaved Myra. Other than we never understood why we have those changes in the maxima.
Mhm.
The minima, let's say, maybe is the companion because it's symbiotic. But just take a look the previous, just this one and the one that is coming, the one that before this cycle.
And that's another thing that I kind of hope to
has a
gather from
bump.
this, and yeah, I think I saw John just pop on too, is what are some good targets specifically where we have visual observers who are doing good time series, and they can keep doing that. But if you have a photometrist who has a capability of doing multiband, which if you're going to do it, I say, please do multiband. Are there some good targets where we could concentrate effort on? Because that was one of the things we did with the LPV program, was try to like herd the cats onto a select number of stars that we have good traditional data that we can derive stuff from. Because if the data is too scattered and everyone's just looking willy-nilly at this thing and that thing, we don't have enough critical mass to figure out anything. How could we go about identifying some targets for a photometrist to say, hey, these are things that we should look at, do multiband photometry on this star specifically?
And on the same subject, what about spectroscopy? I see at least we have a number of spectroscopy users in this group right here. Would that apply to us also? Medium, low resolution spectroscopy?
If you can get enough light to spread the spectrum out and see, be able to monitor the strengths of emission lines, then that's an interesting clue to what's going on in the atmospheres of these stars. And we don't have a huge amount of data to compare star to star in that parameter space. So that's another area of possibility. And I see Margarita's got her hand.
Yeah, let me comment. When we talk about LPVs, not Myras.
True. I know we get into that
Takes
sometimes.
Antares, it takes all the symbiotics, which don't have Myra, but have a giant. There are many, many other, the non-regular, long periodics that we don't have a clue why they are doing what they're doing. And so if we, from this side here, select few, we missed it. We will see the trunk of the elephant, but not the body, or we may see the tail. So it's a very dangerous thing, I think, for the knowledge that we have today, for these stars that we do not understand, including the Myras, to take a selected number and do having the UBV, and the U is most of the time not working, unfortunately. I wish we had beta U and beta B. This is a new tool for us, for the observers, and has barely been used. I'm starved for a good B and U photometry. They may have companions that we don't know. Something is going on in this. And I understand you cannot do billion Myras and so on. But people are doing billion short period variables of this and that and the other, you know. The big thing is with the long period variables, that's why the AAVSO comes. Nobody else observes those, nobody. And if something happens, if Betelgeuse goes off, we are not going to hear it from the Hubble Space Telescope. Well, same for Myra. If Myra switches the mode and does something else, right? We're not going to hear from them. For Ara query, I will give you just very brief comment on this Ara query. It was not this June, the June before. So I have my pet stars that I check on them from CHSIG, Araquari, Myra, Articru, there are others. I check on them what they are doing in the AVSO light curves. So Araquari is behaving fine, was behaving fine. It's a Myra dominating, right? Pop up and down. And so come back from my vacation in June, it was going to go through the maximum, right? End of June, I come back. I said, let me check, beginning of July. I couldn't believe. I thought I got a wrong star or something is happening. Of course, you always blame the observer first. Then the headquarters, then yourself.
As long as they're longer period variable.
Two magnitudes.
Mainly so that they're,
I'm talking with somebody else, it seems.
Yeah, we're getting feedback somewhere.
So 2 magnitudes down. I mean, since then, we have observed gotten all kind of observations, Chandra, HST follow-up, Swift, everything. It's gorgeous. Leanne saw it 40 years ago, but we didn't have this telescope. AAVSO, unexpected. It took my breath away, and it's still we observing and continuing with that. It was expected, but it started early. So it's an example, and thank you, AAVSO observers and spectroscopists. I mean, man, you've been on it, and I'm just elated. So see, if you didn't pick another one, we would have missed completely one of the most impressive phenomenon that we've seen so far. So
You brought up a couple of things that we could probably delve into some more. I mean, you did make the point, and that's one thing I try to, I know I get, a lot of people when I talk about different stars, they want to go, LPVs, only Miras. And I'm like, well, it's a larger umbrella than that, and that are very physically different when you look. But the other thing with the U sources or U-band photometry, I know that's got to, maybe someone who's a better photometer has more experience of that can talk about the difficulties in getting U-band, especially for, these are very red, very cool stars that don't emit a bunch of radiation in that band, as well as we have difficulty because I don't think APAS covered U sources, so we don't have generally good comparison stars in U-band. And I was curious too what the usefulness of specifically U-band, I don't know the answer to that. Like, I know a lot of people look at U-B for emissions or something like that, but what we could do to help facilitate better U-band photometry.
Well, I am not into, I haven't done photometry. In fact, I don't do many observations, as most of you know, but I have looked at high resolution spectra of Miras out towards the U, and there are interesting emission lines in that area. I don't know the extent to which that information can be recovered from any reasonable photometry, but that is one thing that happens out in that part of the spectrum.
And that's something else we could probably look at with the spectroscopy session. If there's certain stars that really saying, hey, we'd like some spectra of, there's a pretty wide range of equipment out there. Obviously, a lot of people are doing very low resolution, but I know if some people, spectroscopy specifically, can get very high resolution and get good data spectroscopically. So that's something we probably just need more coordination with. Yeah, because I know Miras have pretty complex, I mean, cooler the star, generally the more absorption lines you're going to see and things like that.
an example that I would give as well, I'm sorry, I won't be hogging the time, but take Betelgeuse. I did my thesis on Betelgeuse when the dinosaurs walked on the ground. And we've seen these depths. Leo Goldberg, of blessed memory, he saw these depths where you have, probably dust formation and absorption. But AAVSO saw it, and then they followed, right, the others. It was very important, the latest Betelgeuse going down and down and down. Now, if he had a beautiful B and U, the U tells you the blue wavelengths there, tells you perhaps about the hot spots, cold spots, the region on it. Same thing for the symbiotics. For direct query, we are seeing wiggles at the B and U. U is not well calibrated, it's shifted by a magnitude up and down. But if you look just what is happening, unseen things, because we haven't had that as a tool before.
Right.
And
I mean, I
nobody's
could
for a month to observe any of this. And Betelgeuse is a beautiful example of a long period variable that really can blows you away.
Mhm.
Well, if I could add my two cents worth here, can you hear me?
Yep.
Yes, sir.
Yeah.
Okay. I wrote a piece for the RASC journal about Betelgeuse. And the point that I made there is that because the AAVSO has something like 100 years of data, we could actually tie its present behavior to things that it's done in the past. And when you do that, it doesn't seem that much more unusual what it did last year. But the point is that the one thing that AAVSO can really contribute is century-long databases on certain stars. And you aren't going to get that from Assassin or some other more modern source like that. So that's one thing. Another thing is that if you look in the poster room, I have a poster on RUChem, which isn't a long period variable. It's a W Virginis star. But I point out 2 or 3 things there. One is that one thing the AAVSO can really contribute on is observing stars that are unusual, whose behavior or their properties are unusual. So that there may be 500 Myras out there on our observing program, but there's presumably a few of them that really can do with observations more than others. The other relevant thing there is that RUChem happens to be a W Virginis star that virtually stopped pulsating back in the 1960s. And what it's doing now is varying by 1 or 2 tenths of a magnitude on a time scale of 22 days. But both the period and the amplitude are varying in very similar ways to what you find in smaller amplitude long period variables, the ones with periods of maybe tens of days. And if you follow my papers in the AVSO journal, you'll know that I've tended to concentrate on that. I leave the Myra stuff to Leanne and so forth, but getting back to the photometry, that's certainly one area in which AAVSO observers can contribute, because some of the interesting stars, unfortunately, have amplitudes of only a few tenths of a magnitude or even less.
So John, would it be advantageous, one of the files we have up on the section webpage that it's called the file section download is labeled the Percy list paper you wrote a while ago with just long period variables that are exhibiting some kind of change. So would it, okay, if we see them changing somewhat in their period, probably from visual time series, initiating some multi-band photometry on a few of those stars, would that be?
I strongly approve of that, giving some recommendation to observers of which stars are particularly interesting to observe. So if you look in the AAVSO journal, the current issue, I have a paper on V725 Sagittarii, which is a star which changed from a Cepheid into a long period variable. So it's now pulsating with a period of something like 90 days. And so it's now the property of our observing group here. And that's certainly one which I'd recommended in that paper that needs more systematic observations, because you rarely find a star that's changing from a 12-day Cepheid into a 90-day long period variable.
Yeah, well, to follow up on that, I got an advanced copy of that paper. It is a fascinating star. Then I read there wasn't a lot of literature on it, but there were a couple good papers. And it's a very southern star, so you need to be in the south really to observe it. But in the Sagittarius is getting, or I'm serious, Scorpii is getting away from us. But we are going to have a systematic program in place for the next observing section. We have a program is initiated on the Bright Star monitor. It didn't happen. We didn't get any observations this year because they're upgrading the 2 telescopes down there in Australia. but we also, some of the variable star south guys, especially Mark Blackford, had already started some preliminary observations so that when it comes back around, we can do a systematic campaign around that particular star, because it was a fascinating thing is going on, and there's a lot of questions about that star
Well,
particularly.
the other thing I'd put in a plug for, and this is something that falls between two chairs, I think, and that is stars like the RV Tauri stars and the SRD stars, which I think formally are part of our observing group here. But it may be that the short period pulsators group might think that, well, because they're related to Cepheids, then they should be there. Well, it's important that they be either in our group or somewhere else, because right now my students and I are working on a few very interesting RV Tauri stars and SRD stars. We're using AAVSO visual observations because we want to look at some of the long-term changes, actually long-term changes in period, for exactly the same reason as that in the last paper, in this morning's paper session, where you want to find out, well, what kind of period changes do you get with these? Are they increasing? Are they decreasing? Are these stars that are doing blue loops, or are they doing something else? So let's not forget those stars as well.
What I was trying to say as well, let's not focus on pulsating. These are long period variables. Doesn't matter whether they pulsate. I give you a couple of examples, but one of them is called MWC 560. Not much of it. It's a symbiotic with a possible jet that it's looking, toward us. It's one of the stars that has a high mass white dwarf, and the measured velocity in that one with the ultraviolet Explorer and others, it goes up to 6,000 kilometers per second of the jet. I mean, that's a fraction of relativistic. You would see it vary some, and then went down, and now we had observations all this last year of it. It's sitting on a plateau. Something is keeping it bright on a plateau. Now that one has a giant. The giant should be varying, right? It's non-regular, but something is happening, and AAVSO is seeing it. Nobody else is seeing it. Now, when I look at the things, I come also from ultraviolet, from X-ray, and so on. Do you know that there were no X-ray detected in this period when we observed like six months, while before, like few years before, was crashing bright in the X-rays? And now it's sitting there. Another one is Arctic-Crew with almost, we like when their white balls are massive, because if we dump enough material, maybe we get a path to supernova type 1A. So if you look from AAVS, so it's doing something, not much amplitude, it's changing in a longer term. But 2 years ago, suddenly it went up. Swift detected it as a gamma ray source. It's a hard X-ray source, is this particular. But if it wasn't followed, we would not know, now is the time, let us go do a campaign, let's call what the other telescope, multi-mission, multi-telescope. So not the pulsating only, the long period variable with all kind of objects that if we just select few, that's what my worry is, right? I wouldn't have had data for, if I had only the X-ray observations for MWC, I got HST and X-ray on that, and didn't have the light curve. Didn't have this, to see this, wow, what's going on with this? I would have thought, well, no idea. So see, the AAVSO light curve, and there is, because it was a campaign as well, I get the V and the B, it tells a lot. It's probably a new jet pumping, making the cool thing bright in the region. We don't know. So anyway, that's why I'm pushing for this more global view. What you know, it's easy. What you don't know, but you follow. It makes
Yeah,
us
that's a message I try to put on sometimes. People are like, well, it's not doing anything. I'm like, well, how do you know it's not going to do anything? You know, you have to have a baseline to compare it to.
yeah, but can go kaboom.
Right. And maybe we should switch gear. You know, one thing we're sitting there talking, we just jumped in a bunch of science stuff. And, you know, fortunately, I know a lot of the people on, but we should probably introduce some of the people online and just what your interest is in variables. And so everyone can know. I'm just going to go in order of my screen. Frank Parks, you introduce yourself and what you're about. You're about symbiotic stars. Well, you have a great.
Wow. Our
Margarita is your
on my list.
Yes, yes.
Spectroscopy. I know I work with Bob Buckheim and let's see, I saw Bill Goff in here. We have Lisa spectrometers R1000. So I plan to add our Aquarius and long period, but I also have BVRI filters. So I should do more mere long periodic variables. But I'd like to flux calibrate my spectroscopy data. So that means I go get photometry data, calibrate my spectroscopy, flux calibrate it. So we have something that's very comparable with others. So, but I'm fairly new, but I have been doing some photometry data. And I've gone through some of the classes here, AAVSO.
Okay.
I'm in
Well, you need targets. If you go to the section webpage, there's a button on top to send me an email, and I could probably find some for you and talk to some of these people on the call. And we can get you some good targets.
All right, great, thank you.
All right. Well, Leanne probably doesn't need much introduction, but we'll let her.
I don't know everyone here yet, but Leanne Wilson, and 6 years ago I retired after 41 years teaching astronomy at Iowa State. So now I'm like the rest of you. I do astronomy without getting paid, and I also do some other things. And my approach, I'm not a data producer, I'm a data user. So I'm one of the people who gets digging into your archives to find the answers to questions. Many years ago, Janet Matty and I and Peter Garnovich noticed what was going on with our aquarii, and I've been waiting 40 years for it to do it again because we just missed the last one. So this has been exciting times for that. And most of my work has been on MIRAs, which are the heavily mass losing phase of stars like the sun. And I've been trying for years to understand the mass loss process. So that's where I come from. Great.
And like I said, as a data user, always looking for suggestions on what data to provide, and some of that's already come out. Simon, can you tell us about your interest in what you do?
Yeah, I'm based in the UK. I'm interested in doing visual observations of the legacy stars in the program.
Okay.
And also binocular variables. I did notice on the lots of the talks that it's all about photometry. There wasn't really anything on visual observers.
So that is a big passion of mine, because we get we kind of, people start to think, oh, we don't give love to the visual observers. And in some ways it's not as glamorous is the photometry, because you can do other things. You can learn a lot of details about stars from multi-band photometry. But if you look at visual data, still has a lot of use, and especially in our realm with the longer period variables, because they're well suited to visual observers and with their periods not changing and their high amplitudes. And the other thing is, most of the stars, especially the long period ones that have high amplitudes, we have 100 years worth at least of visual data. You can't really transform Johnson V filter to an eyeball filter and come up with anything. So we can, people like John uses visual data quite extensively if you read his papers from the AVSO to find out what period changes, amplitude changes. It tells you what stars are interesting.
Yeah, the point is that if the stars are periodic, then if you've got lots of visual observations, you can simply use statistics to beat down the error, and your visual observations are very useful.
One last thing, I've always been wondering, do you have more visual observers than you do photometrists?
Yes. Now we have more visual observers than photometrists. Photometrists produce way more observations,
Yeah.
number wise, than visual ones, because a lot of them are doing short-term time series on, like, some of the stars that they talked about in the talks have periods of like a couple hours, and they're taking 500-600 observations of the course of 5 or 6 hours. You can produce good information from there. Obviously, you're not doing that as a visual observer.
Oh, that's not the only reason. The other reason is that CCD can hit 80 Myras a night in 3 filters.
That's, yep,
All
that's true. And there's a
transformed.
lot of times there's other variables in your field, so you can get just guys next to you.
But
So
the visuals are the backbone of AVSO. That's your long-term observations. And I would suggest to take a look, many of us have seen it, is CH Cygni. Don't look at the B and V visual. It wasn't doing anything before, I don't know, 40s or something, just little wiggles there. And then it's a symbiotic, went into an outburst. Look what the light curve looks, just the visual. Now for our query, the first sign is the visual observers. It's not the photometry and when it dipped. It's key, for me it's key. I first see V, then I go and check what for any of the long period variables. I see the visuals.
Yeah, I want to echo what Margarita said. So 4 years ago, I said, well, one of these days, our query, I should start to do something. So I went to look at the AVSO light curve, and lo and behold, it was having a low minimum. So I sounded the alarm, and people started taking a lot of multicolor photometry. Well, it turned out the next cycle was normal. But now we have several cycles of all that good photometry leading up to, oh, wow, it went through the basement. Okay, so now we have that enormously valuable data. We wouldn't have had that if it weren't for the visual observers keeping track of the star. The other thing is when you're looking at period changes, and a lot of these stars have interesting period changes, and some of them are very interesting because they signal what's going on inside the star, you need a long timeline of compatible data. And as noted, these stars have, in many cases, 100 years or more of visual data. And you need to be able to extend that timeline to get more signal on the period change information. So it's important to keep the visual observations going, even while we augment them with multicolor photometry and spectroscopy and all the other things that can be done. It's really important to keep the visual observations going.
And what Simon said, by the way, Richard and the organizers, the LPV, what you said, it's true. We need more visibility of the visual observers when we have our meetings.
yeah,
Review
that's a good point.
Talks by the observers, because you are not a negligible part. You're the backbone of AVSO. You're the past, the present, and the future.
Not the future.
But one warning that I'd make about visual observations, and if you read my students' papers in the journal, we've looked at several hundred long period variables, mostly of the semi-regular and irregular type. And for the vast majority of them, either the data's far too sparse, or in fact, the data we've got is saying that the star is really not variable, or it's microvariable at the most. And yet those stars continue to be observed visually. And there really needs to be some warning about, these are stars that no longer really warrant any ongoing visual observations. Choose the stars that really are worth observing.
Yeah, that's a good point, because people say, what's better, photometry or visual? They do different things, but really the visual's only valuable if there's enough critical mass there to be useful. And there's a lot of stars out there that people are observing scatter plot, and I'll look and be like, you can't tell anything from that.
If that was
the professionals want the photometry. They don't want the visual stuff. It's not accurate enough.
But if that was the case, we would not have had our query observations and CH-SIG.
Yeah,
We
I mean,
would
it
get
is a backbone
lobes
maybe.
and
It
said
gives you
not
ideas.
interesting, doing the same thing, and those are one of the most interesting objects. We would have started observing them. That's I'm trying to, make that point. We would have started observing them as non-interesting visually. They repeat themselves, is the same. We would have stopped in the 40s observing Sig. Please take a look at the light curve.
I'm going to challenge one thing that Jay said when he said that visual. Now, not just because it's photometry does not mean it's accurate. There is a lot of poor photometry out there.
Yeah, well, of course.
And there's a lot of people that don't understand how it goes. So, I mean,
yeah,
depending on the circumstance, visual can be perfectly fine. If you look at most visual observers, it's more accurate than what you're getting out of like Assassin and stuff like that, because they're not that concerned with accuracy. So, but you can still tell things from it.
yeah, sure.
Good photometry is a different story, but what photometry really does when you get it in multiple bands, again, something the eyeball can't do, it can tell you physical properties that you're not going to be able to.
Well, since you
discern
just mentioned Assassin, one of the things that we haven't talked about is the possibility of doing data mining on long period variables. And you may have noticed last year I had a paper in the journal with Lucas Finot. And what we did is we looked at a sample of the Assassin stars, which had been classified as Mira stars. And so we found that 2/3 of the classifications or analyses by the Assassin automatic system were incorrect. So there's a huge potential for actually doing data mining in places like the Assassin database. And first of all, identifying stars that are really, really interesting. And we did publish an example, but also looking at their classifications and periods and saying, are these correct? And the answer is, well, usually not.
It's another good point, because when I heard Eric, when we talk about visual observations not being the future, and I agree with that. When we get enough survey data out there, that's probably what we're going to go to time series. And as we've seen, the observation cadence on a lot of stars, I don't think visually are being kept up. There's a few that everybody observed that might be fine, but sky surveys and binding the data that's out there, because the algorithms aren't going to always be right. I've seen a lot of actually where they're wrong a lot.
To the professional needs.
The challenge with surveys is making sure that they go on for a century. And to date, that has been rare. Maybe in the future, there will be ongoing surveys that are permanent. But for now, the only ongoing survey that's permanent is visual observations.
Mm-hmm.
But is there going to be a standardization where if they all kind of agree, and I know that they don't, on a specific pass bands that they're using, or that we can transform back and forth, where we can get continuity there?
I doubt it, because what happens is that projects are funded to do something new. They're not funded to do more of the same. And so you build a new survey around a new way of managing the data, a new cadence, a new set of band passes, a new way of picking your star. You build new surveys around new ways of doing things. And once you've done that for 10 years, most of the projects that were meant to be addressed by that survey have been addressed. And so then you go on to a different survey. So I don't really see, I could be wrong, but I don't really see us having a survey system in place that gives us long-term, continuous, compatible data for stars. I see, a year, 10 years, maybe even a little longer, but I don't see decades worth of data coming out in a consistent fashion. The only place that that's happening still is the visual data. And to some extent, there's still a lot of people are using UBVRI, so that produces data that can be compared with a little analysis and correction for each person's instruments. Yeah, I don't see surveys taking away the need for continued monitoring by consistent instruments like these.
Well, let's get on the pocketbook.
Absolutely agree. Absolutely agree.
But we got to try Dawn when we were at Simon. We were going around the room with introductions. So I think we're on to John.
Who, me?
Yep, tell us a
I've
little
said
bit.
enough already.
All right.
I want to hear from some of these other people.
And Margarita's talked a lot. Or Jay, tell us about yourself and your interest.
I'm, let's see. No, you can hear me.
Yep.
Yeah. Okay. Actually, primarily, I've been a solar observer. It's hard for me to set up my telescope in the backyard. I've got a G11 mount, and I've got a bunch of telescopes everywhere from 80 millimeters on up to a C11. But it takes a lot of time to set it up. I've got a limited amount of sky. I have no west because I've got a forest to my west, and I've got a big tree towards the south. So that takes up some of that. I've got the east and some of the south. So I'm limited in the amount of sky and as I said, the time to set up. So I haven't really gotten into nighttime observing that much. But certainly when I do, I will probably start with visual observing of long period variables. And what I'll probably do is just pick out one region of the sky and pick out all the, maybe the long period variables in that and follow them for as long as I can until they go into the trees and then go to another set. I did get a G filter a couple of years ago because at the AAVSO meeting, I had asked one of the professionals there, who was giving a talk, what do you use? And they said Sloan filters. So I got a Sloan G. But the problem is the AAVSO doesn't have a way of using the Sloan filters, only the Johnson cousins. They will eventually, but not yet. So I'll start out with visual.
That's a good place to start. But I think Eric has some opinions on Sloan versus Johnson. And I do think that Sloan is going to be more ambiguous than Johnson here soon. But
well, I think Sloan,
ubiquitous.
That's what the professionals use.
Yeah.
And that's what the new catalogs are coming out in.
Mm-hmm.
I mean, the way that V comp star magnitudes are set up, it starts with Sloan already. And then they're transformed somehow into some fake V standard magnitude in AAVSO's own comp star lists for the Percy list and everything. I don't understand this.
Yeah, I mean, that if they're doing that kind of transformation, just publish the Sloan values.
Yeah, I've suspended I have 80,000 Myra observations on 200 Myras and semi-regulars, and I've suspended my program until the AVSO catches up.
It makes me sad. Eric has beautiful data out there when you look at his curves. I can always tell when I'm in like her generator, I'm like, oh, Eric must be on this star. And sure enough, when I look, it's obscure. Mr. Buckheim.
Hi.
Hey, Bob.
Frank mentioned spectroscopy. Do I dare share my screen to show you a picture?
Would love to see it.
Okay, let me see. Oh, host disabled screen sharing. Apparently I can't.
Oh, I can probably, I may have to do something. Allow, let me see here.
The story is, I had started.
Can you share now?
Yeah. I had started looking at the spectra, low resolution, R is 500, of a variety of Myras, mostly as a gee whiz project to see if I could see anything changing. Do you see that stacked spectra?
Yeah.
Sure do.
Yeah.
Okay, so on top is, this is V Core Bohr. This year on April 5th, and then below that is May 22nd, July 15, and August 7. And, you know, the general trends are kind of unremarkable, but those last two spectra, something happened in H alpha. And maybe whatever this is, let me see, the wavelength is about 5899, 5890, maybe something going on there. Is this just gee whiz, or might there be some actual scientific information coming out of following these stars through one or two cycles?
Well, emission lines in hydrogen that come and go during the cycle is characteristic of MIRAs. And one of the interesting features of those emission lines is that they tend to have overlying absorption by other material in the atmosphere and also by hydrogen. And so there is a modest amount of information out there about how those things change for individual stars. We have a few stars that have been well studied, starting with papers by Joy and Merrill and so forth at Palomar in the 40s. But there's not been a lot of this kind of study done. Now, Bob Cadmus at Grinnell has been doing spectroscopic monitoring and photometry and on MIRAs and semi-regulars, more focusing on some of the stars that have not so regular light curves. But he'd be a good person to be in touch with if you're interested in doing that kind of project.
How do I spell the last name?
Cadmus. He's retired faculty at Grinnell College in Iowa.
Great. Thank you very much.
When you see the deep absorption, can be also the troughs of TIO bands. The troughs, they go sharply down and then come up, depending of the phase. Do you have the phases of the MIRAs in what you have displayed there?
I have not correlated the spectra yet with magnitude.
That will be very good to see which phase, whether it's at the minimum, whether it's on the rising, whether it's 0.8, 0.6, 0.4, because those Balmer lines have a tendency to appear at a certain period, go up and down in MIRAs, and same with the TIO band. The cooler it is, that is going to the minimum, the TIO troughs cut sharply through the continuum, but very interesting work, very beautiful spectra. Thank you for sharing.
I have a question. I don't know that if this would be real relevant. One thing I've read a lot about recently are, basically circumstellar disk around very evolved MIRAs and carbon stars. And some of them are very bright and pretty close. Would getting AVSO spectrophysis onto those stars, I'm thinking like RS Canceri, TX Pisces, would getting some spectropsy on those stars be really beneficial, or something that we should probably direct people to?
I'm guessing photometry would be more useful than spectroscopy for those, for the disk setup, just to look for time variations rather than to look for variations with wavelength.
Yeah, well, RS Canceri, I actually have a BSM monitor, so I'm getting photometry on that star. I have a lot of trouble with the eye. I get good BVC. It's tough because these are very bright stars. I was trying on TX Pisces. It's like it's above 5th magnitude most of the time. And I'm gonna have to send it to a PEP guy. You can't really do it. It's hard with the CMOS. Mm-hmm. There's no good comps, so it is not, I can't get good data on it. But I was wondering.
Well, yeah, if you can't get photometry because it's too bright, then a spectroscopy might be useful because you can at least you can fit the overall shape of the spectrum, and that can be useful information that way.
Yeah, I mean, they have really interesting, I imagine the spectra's got to be interesting when I know we've looked at those stars specifically a lot in radio and mapped out the huge extended structures, which there's a lot of structure in the shells themselves. Anyway, another tangent. So we just did Bob. Who's after Bob? Todd, you tell us a little bit about your observing and what you're interested in?
Sure. Yeah. I'm sorry. I just joined a minute ago because I'm kind of making the rounds to see what all is going on. But so I teach astronomy and physics at a liberal arts college in Oregon, Pacific. And so I guess my research background is actually in cosmology, but I got my astronomy start with the AAVSO back when I was in middle school and high school doing RS-CAN-Venn variables. So I'm mostly involved in kind of outreach and education kinds of things now. So I dropped in here kind of to get a sense of what, I'm looking for projects that I could get the public and students involved in, easily. So visual observing obviously is appealing. So just kind of seeing what's going on.
That's one thing that I've wanted to try to do more of is identify faculty at colleges and try to give them projects. I know when I was a astronomy student 20 years ago, we did, I went to Virginia Tech. We had a small observatory out in West Virginia that students got to use. And we did like asteroid hunting and stuff like that. We got to submit stuff to the Minor Planet Center. I didn't find out that the AVSO existed until like 25 years after I graduated with a astronomy degree. And I was like, we could have done projects with that 0.4 meter telescope out in West Virginia that would have been cool. I would have loved to do it. But I didn't know it was out there. I don't even know if our faculty, they were radio astronomers, the three of the astronomers at our physics department. They may not have even known that we existed. So trying to help facilitate some of those connections and saying, hey, we have remote scopes out there. If you have students who want to I've done it, it's easy. You go and say, hey, this is what I want. The system's like 50% utilized. They'll start getting you good data. Transform coefficients already done for you. Go straight into VFOT and you can do your analysis, or you can put in AIJ or something, or Maxim.
But the great thing about the AAVSO is that the students can make a few observations of their own, but then they can use the entire AAVSO database for actually analyzing and interpreting what the results are.
Mm-hmm. Yeah, I really like that point about, in fact, John, I think maybe you were involved in there was a paper that came out recently about using cell phones for,
yes.
for observing, so I like the idea of, because I have a sort of a growing group of students who are super excited, basically just give me something in astronomy that I can do that's real, that will, connect to the research.
Yeah, the whole point of that paper was you can go out with a standard smartphone, you take an image of Cepheus, and then you can make estimates of delta Cephei, which are just as good as the ones you'd make visually.
Yeah. And then, like you said, then they have the experience.
You've got an image of something.
Right. They can share it on Facebook. They've done it themselves. And like you said, they can tap into the whole data set that the whole AVSO has. So
that's right.
But yeah, I think there's a lot of good opportunities. So
yeah, if you're looking for stuff, like if you go to the web page and there's a section called observing sections, you find, well, any of the observing sections, but long period variable specifically, there's a button on there that says contact. It'll send an email to me.
Okay.
And so if you were looking for ideas or people to talk to, I could probably get you in touch with the right people or suggest projects around long period variables and like the short period pulsators. Those are nice and easy because you can do things in a night if you have observing time. And it's tougher with a student to do something with maybe a long period variable that has a 400-day period. But you could do a Delta Scuti star in a night. And Eric Heinz he's a professor, so he could probably give you projects. He also does a lot of data mining of surveys to try to find where the surveys, as Eric brought up, misidentified things or have wrong periods because they're picking up aliases, because it's all his algorithms, not a human looking at it. There's a lot of opportunity to do real things that's perfect for a student. Yeah, especially at the undergrad level, that would be fun and cool, and actually doing something tangible versus sitting in a lecture hall.
Exactly.
I'm sure you don't put them to sleep, but I won't admit whether I ever got put to sleep during a lecture or not. And much more enjoyed observatory time and doing labs and getting lectures.
Right. Yeah.
All right.
Cool.
Appreciate you dropping by.
Definitely send you an email. Thanks.
All right. Sounds great. And we're on to
shows Bob Buckheim wanted to get in touch with me. You know, next Friday would be good because we were going to talk about some outreach because I volunteer at the Air and Space Museum in DC.
Friday was, that's good for me.
Okay.
I'll set up a Zoom meeting.
Okay. All righty. Just, yeah, just email me. You've also got my, I emailed you my phone number.
Great. Thanks, Jay.
All right. And we're on to,
That took care of some other business.
all right, man, being productive, I like it. All right, Eric's up next.
Well, you've heard from me, and I have some data out there. If I can look forward maybe instead of my past, I think I took on every Percy's list variable that was available to my latitude, to my scope size, and that had good comp stars. And I followed them. I started about 1.5 years, 2 years ago, and did about 1.5 years worth. The biggest constraint was comp stars. And that seems absurd to have Percy's list up there for several years and comp stars are simply not available. You know, we talk about having data that matches each other's data for long period variables because you are having to interleave people's data. And if you do not transform, there's no hope for these red stars. No hope.
Sorry, that's not my department.
Oh, I'm not picking on you. In fact, I've demonstrated with the Swedish observers of MIRAS that if you both transform, your data sets are indistinguishable. They interleave perfectly.
Yeah.
Okay, so transforms on red stars are absolutely mandatory. You can't transform eyes. That's the problem there. U and B are not going to be possible for MIRAS, for most MIRAS, for amateur telescopes. We can't reach them. Maybe at maximum, but some of these have V minus I colors of 10. That is, I is 10,000 times brighter than V. Forget about B. Maybe with CMOSs, this will get a little better, and the trend is toward bigger scopes, but I worry that we'll ever get over that for most interesting MIRAs and very red semi-regulars. So the place where we can make a difference is in the comp stars. And it seems to me there should be set lists of a go-to list that you point to for new talented observers. Percy's list is a great foundation for that. And just make sure the comp stars are really available. Some of them have I band uncertainties of 0.4 of a magnitude for a standard star. This is nuts. Okay, if you go to the Sloan catalogs like the new Atlas RefCat 2, all the stars cover all the sky in all Sloan filters or pass bands to 15 to 20 millimagnitudes. That should be the basis, and it will be the basis. So somehow we've got to get this comp star system under control if you want consistent and long-term red star magnitudes.
Now
So
that you
that's
make
my
some,
pitch for the future. I don't need to introduce myself, but I'm much more concerned about what this talented group of people does and making sure they have the resources to do it. And to me, the big gap is comp stars.
no, you bring up some good points, and we're trying hard. And I was really glad to see Ed and Ken's how-to hour. I don't know if you caught it about the importance of transforming. I think that hopefully brought some, put the light bulb on for some people to actually do it. And, but you're right about the comp star thing about standardizing our stars. And I don't think that the ones that are in there as the AVSO comps right now are particularly up to snuff.
That's how I had to limit my list. I simply ran out of MIRAs in the entire catalog that
It
had
works
good
better
enough
without
comp stars.
headphones.
So
That had, hello?
I'm sure you brought this up to the sequence team. I know whenever I try to bring stuff up to them, they get kind of defensive.
Well,
but
how can we have current catalogs out there with 200 standard stars in every field of view and have no stars in our comp star list better than 0.4 for I? I mean, this is a disconnect that's global. It's not on a star by star request. But if it needs to be done on a star by star request, this group of people right here are the best ones to start improving them in batches of 4 or 5 stars until Percy's list is fleshed out with comp stars and the rest.
So I have a question. Did you submit those stars that are on Percy's list to the sequence team to say, I want good sequences for all these stars? Or were you just going off what was already there?
I can't say that they were uncooperative. That's not the case because I really didn't make many requests. In fact, in Percy's list, I don't know if I made any.
Right.
But it is a cumbersome process, and I don't understand why, for example, we have no comp stars for new alerts. Sometimes we have alerts and the comp stars aren't available. How can that happen? Well, I don't understand that part of the process at all. Never have.
Yeah, I know. And I challenge getting good, especially V and especially I, comp stars.
And well, R is absent from a lot of them, and maybe that's okay. I stopped using R because it didn't add that much if you're already doing transformed V and I.
Mm-hmm.
B was too hard, was too faint at minimum for almost all the stars I was looking at. Got nothing to do with transforms. So yeah, I think for these very red things, they're hard to do, and I think AAVSO would be well advised to have a step-by-step ladder of increasing by difficulty for these aspiring photometrists, because Stella says that it's just too high a wall for many people to look at in one piece, and I would agree with that.
Yeah.
Thank you.
You bring up good points, and I know it's been tough. But I think we do have to get some more consistency on how we do things, so people who are out there doing photometry are using similar methods so that the data is more consistent. See who is next. We've been going around the room, and I know Mac user, you're next on the list, and you just popped in. So we've been going around kind of saying, hey, what our interests are, what issues you have, and really what's your real name.
Invited by it's Mac. What makes you think it is a Mac user? I was invited by Lindsay, so I'm just observing. I don't know much about the group. I just learned about it a couple days ago, so I'm just here to watch.
Okay.
I'm jumping around to different groups, and thank you so much for
What
having
is
me.
your name?
My name's Jainaba. No, my name is Jainaba. I don't know why it's coming up as Mac user.
Yeah.
But
Nice to meet you. Nice to meet you.
I'll probably go pretty soon. I live in Paris, and I'm about to eat dinner. So I think you guys are probably mostly in the U.S. But yeah, I'm gonna bounce pretty soon. But this is fascinating. Thank you so much.
We're all jealous.
Very nice meeting
you. We are not in Paris. Having visited there once, it was
well,
great.
Not French, obviously. I'm from Brooklyn, so yeah.
Actually, interesting. My younger son lives in Switzerland, and he went to school in New York and lived in Brooklyn.
Oh, get out of here. Yeah, Switzerland is beautiful. Switzerland's really beautiful. Yeah.
What are you doing in Paris?
Let's see, we have
Muting myself. Nothing interesting, but I'll let someone else talk.
Are you there, Kim?
Yeah, I'm here. Can you hear me?
We can hear you.
Okay.
See
Basically, I just have equipment, and I'm just trying to see what it is I can do with my equipment, because I don't have a large scope. I have a small refractor. I do have a Dobsonian, and right now I do have a small camera, but I'm basically a visual person. I like my eye to the eyepiece. So I'm just checking it to see if I can do long period variables and see where I can go from there. And I'm
Yeah,
also in the section, so
And you're also a solar observer.
yeah. And I do the solar stats. Yeah.
Yeah.
Yeah, there are a lot of bright LPVs out there, especially when they get to top of the range or even into binocular ones if you have a small scope. And one thing that's useful about the brighter stars is when we talked earlier about the massive surveys that are out there, most surveys, you know, they consider like 10th magnitude or 9th, you know, bright. And so they're not covering stars that are, you know, 6th, 7th magnitude. So there's a lot of targets out there that are in reach of small scopes that aren't being covered otherwise. So it gets important for binocular observations, small scope observations to catch all those maximum. As we talked about earlier, MIRA itself, its maximum is not consistent from period to period. So we got to be able to chart that. And when it's 3rd, 2nd magnitude, that's not being observed by any you know, professional equipment. No surveys are catching that. It's really on us to monitor these things.
But then are those stars actually being used for observation?
Yes. The funny thing, one of the biggest stars, because you get your data report every week. The one that been getting pegged on of my observations recently are my naked eye observations of Betelgeuse that I was doing every night. But a lot of those bright stars, they look at the visual observations because there's no other data for it. You know, you can't go to a lot of these surveys and pull data from it. So those do get used.
Okay.
Just a little vignette, if I may, for the visual observers, very, very quickly. We remember, and it's a good time to remember our dear friend, observer Albert Jones from New Zealand. He was visual observer, and I would bet on his observation or anything that he had done that we collaborated on. So, but he is the one who saw the rise of supernova type 1A, supernova 1987A. And this is the nearest supernova that we have seen with naked eye, so to say, in 400 years. He saw it before everybody else. It was like 7th magnitude, 6, 7 magnitude visual. And it's a critical point for all the models that got developed about, you know, the explosion of that one. So
right place, right time.
That's the visual observers.
He was based in New Zealand, wasn't he? He was a New Zealander, wasn't he?
Oh, she's back on mute.
Right, he passed away just 2 years ago, but a wonderful observer, wonderful, and a person. We remember him.
Mm-hmm.
Okay, so does John, on your list, do you have some long period variables that are bright that I can look at?
The Percy list that we've talked about before, which is on the section webpage, some of them are probably bright enough to be within your equipment. There are also listed on there is the LPV program. Most of those stars are actually fairly bright because those are the ones we have the most observational history on. And the ones that were discovered first were, of course, the bright ones. There's also the binocular program, which takes stars down to, I think, at minimums of 7th, 8th magnitude range.
Yeah, Kim, you're
you
welcome
can
to get in
find
touch
stars
with
there,
me.
too.
I have all my own favorites.
Yes, I know, I have your book. Okay, thanks.
Yeah, so that's where I would recommend go to the section webpage on file section downloads. There's lists of program stars. Also, if you do, if you get proficient in VSX, you can search areas of the sky. And what I normally do is put a limiting magnitude in there. So I get lists of stars that are just brighter than the minimum that I can see. And so you can find targets that way within a certain, when you learn your observational constraints, you can put that into VSX and get a list of targets that fit your parameters. That's a good place to go. You can also search down at the bottom. There's a drop down that has campaigns. So if you're looking for specific SARs in VSX, those campaigns are, the Percy list is one of the ones you can look at. The binocular program is one you can sort in VSX. Say, give me the binocular program SARs, it'll populate all of them, or you can put constraints about what sections of the sky you're looking for. So VSX is an awesome tool for planning your night.
Okay, great. Thank you so much.
Probably better than the target tool, I find. But that's just, let's see, Bob, you're up next.
Hello. Okay, let me show who I am here. There we go. Okay. I'm a long time AAVSO member and observer going back to high school in the 60s. Done mostly visual LPVs with a few years of PEP SSP3 photometry. And then I moved to the city, Rochester, New York, and sold my scope. It was too heavy to carry around, but since like last month, acquired Orion 80 millimeter refractor and a nice go-to mount. So I've been starting back visual observing, and I also have a DSLR, and I've been combing through the DSLR CCD observing requirements, and hope to do some LPV observing with the DSLR in the green and transform them.
Good deal. Scott, I think you're our last one.
All right, thank you. Can you hear me?
Yes, sir.
Okay, very good. So my name is Scott Donnell. I've been with the AVSO for a number of years, but I started initially doing observations of LPVs visually. And then within the last 10, 15 years, added the capability to do BVI observations, yes, transformed. And I have my observatory set up to generate just a run all night robotically with software that I wrote. So I can typically do 10 to 20 or so targets on a clear night. That being said, I generally have observing windows that are one or two nights per week. So this tends to lend itself well to generating data for the LPVs. So looking at the bottom of your long period variable section, at the very bottom, it says you should look at the full LPV program, et cetera, and find the stars that are right for you to and worth adding to your observing program. So that never really gave me much direction on what the AAVSO would like to see. So barring any specific direction or desires on how observers like myself could contribute, what I did was I focused primarily on those LPVs in the target tool that were in need of some more observations. Maybe the last observation was 2 weeks ago, a month ago, something like that. And so I'll add those to my observing schedule list and then put them in the schedule. So that's kind of how I did that. So I consider myself to be a support. I think there's three types of contributors to AVSO database. There's observers, there's supporting observers, and then there's researchers. So by observers, I'm talking about people that would make either visual or photometric observations, and just for whichever stars they choose, and put them in just to keep the population of variable star observations going. Then there'd be supporting observers. So that might be someone that would be contributing observations to a campaign, like for example, the recently announced Northern T Tauri Stars campaign. And then there's researchers, those who are going off and engaging in specific research topics on particular stars. I'm not a researcher. I have been acting as an observer. I would like to be more of a supporting observer. So that's kind of where I'm coming from. Just want to make a couple final points before I conclude. One is that I tend to focus my observations, given my camera setup, for fainter objects and objects that are on the faint end of the cycle. I think that the visual obs are valuable for brighter objects and objects near the bright side of the cycles, since they would tend to saturate my images. And another point about visual observing is that, we often talk about the graying of our hobby. We look around here. I don't see anyone much younger than myself. I don't see any teenagers out there. We talk about trying to attract the youth, the new people, the young blood into astronomy. And I think that visual observing is a great entry point to attract those individuals that will then later become supporting observers, become researchers, and so on. All right, I'm done.
Got some good points there. Yeah, that's one thing I try to look at for outreach opportunities. We definitely need, Stella and Gordon laid that out pretty, I think, well at the membership meeting, some of the plans and the things that we needed to do to target certain individuals and bring them into the fold.
Emphasize to young people that they don't need $10,000 worth of equipment to do variable star astronomy.
Yeah, it's one thing people want to jump into photometry so much. I'm like, photometry is hard. It is really hard. You have to have and it's not cheap. You really got to know what you're doing. And you can be led astray in a lot of ways. And you don't need a lot of, you can do visual on a budget, and you can still find ways to be useful if you are doing it right and you're thinking about how you're.
Yeah, I mean, with my astronomy club, it's all older people. It's difficult getting the younger people. We, before this year, we would give out awards at the local science fairs. And as the kids would get a year's membership in the astronomy club and a year's subscription to Sky and Telescope, but you never saw them.
How did they get all these awards?
They would get the very seldom, I think, would they bother coming to any of the meetings.
Oh,
So
you should require it.
That's one thing I always ask myself too, because my local astronomy club, I've tried to get some people. We have some very advanced astrophotographers, and I'm like, stop taking pretty pictures and let's do some science, but I haven't won any of them over. But our club does an amazing amount of research, not so much now in 2020, but going out to elementary schools and getting people excited. And I live in Virginia Beach, Virginia. We have a big boardwalk on the ocean. We take scopes out there every month, set them up on the boardwalk, people going by. Most people are very, they find this interesting, and they love this, seeing the planets. It gets people energized. But as far as becoming an observer, the impetus to buy a telescope, I don't know if that gives you a lot of bang for the buck. That's why I'm wondering too, we were talking with Todd earlier, can you get kids at the undergraduate, go to physics departments, get them involved somehow, because those people are probably more likely to be involved in somehow. And plus you also give opportunities, we had some college students give talks during this meeting, which I think is great. That's great opportunity for them. At SAS conference, we have Bob who's very involved in that organization. We had high school students and we had some undergrads give talks. So finding a way of getting them energized in that manner, is that the way to go for it? Did you have something to add, Todd?
Well, yeah, I was just going to kind of second what you were saying, right? I mean, that's been our experience too, is Erica, who was my undergraduate student working with me, we've just started doing the research rather than having people, coming to meetings is one thing, but if you're just actually doing the research in a space, like on the boardwalk or whatever, which you can do with variable star research because you don't need dark skies necessarily. And then people of all ages come by and they're excited about what you're doing. And they, if you can hand them a finder chart and have them start making, or use their cell phone, if you can do it that way, right? And have them start making observations of Betelgeuse or whatever. And then, and then they have this sense that, it's not something I have to buy thousands of dollars worth of equipment for or whatever, right? I'm doing it right now. I'm a scientist now, kind of thing. I think if you can create that energy, that kind of feeling, kind of out where people already are, rather than having all the hurdles of them having to come somewhere to go to a meeting, or what I mean? You can sort of get them involved at that stage, and then maybe they'll have the enthusiasm to go the next step, kind of.
Yeah, it's another thing, getting people out to a meeting. Like I said, again, my club, we have like over 1,000 members. A lot of people are very active in Facebook and groups, but when we have meetings, it's like 20 or 30 people.
Right.
I'm 40. I'm the youngest guy there always. But we have people who come out to our events that don't come to our meetings, but they come to our observing events, and they tend to be younger. They'll have a scope, and people share knowledge. Come to star parties. We'll share stuff on the Facebook page. So just because you're not coming to a meeting doesn't necessarily mean you're involved, but I think just being out in the community as much as you can, you might inspire some kid, like, so most of these kids are going to be like, wow, that was cool, and never think about it again. But you never know how many of them say, wow, that was cool. And you set a little train, something in motion that, that may inspire them to pursue something in physics or science or something like that.
Richard?
Yes, ma'am.
May I ask an important question actually on the LPV observing? How are we doing with the LPV observers from the southern sky, southern hemisphere?
How are we doing?
Do we have observers? Do we have, how we are outreaching the observers from the south? So we get some of the southern objects covered.
I have been looking for projects to do with the South, and that's why we mentioned V25 Sagittarii earlier. I send it down to those guys, and they seem to be enthused. But Variable Star South has their own long period variable section, and they do pretty good work. And they strive more so probably than the AVSOs. Their members are expected to come up with publishable material for papers, which they often publish in the JAVSO. I communicate with those guys on a semi-regular basis, generally through email. I've done a couple of web calls with them too. Zoom makes that easy, but time doesn't always.
I'm thinking of coverage of light curves that I can get from AVSO of southern objects.
Yeah, I've talked about that. For one thing about the observers down there in Australia and New Zealand is they like to not put their data for whatever reason in the AID, and they like to keep it themselves. They have their own databases, and I get to if they're writing a paper, they hold their data till it's published, and I always say, well, after you publish, go ahead and put it in. Some do, and some don't.
One benchmark there, or source for ideas, a lot of the southern observers I know, or people with scopes in the south, look at cataclysmic variables. That seems to be a real strength in the southern hemisphere for people associated more or less with AVSO. You may want to sniff around and find out how they're succeeding where we're doing a little less well.
Yeah, one of the other big pushes they have down there with long period variables are the dual max MIROS. Stan Walker ran that program for many years, but Stan's 88 years old now. And we had a webinar actually in conjunction a few months ago with them, and they presented on a couple really interesting stars that have this unusual property. We haven't found any in the northern hemisphere that I know of that exhibit this behavior. One of the great things about it, we talk about spectropsy, is Stan was presenting, he was lamenting about how he didn't have any spectropsy on any of these stars, and then Percy Jackson, who lives in South Africa, is like, he put up his hand. He's like, I got Spectra on these stars, and so gave him the screen, and he pulled up our spec, and we started looking at the absorption lines. So I think they are actively looking for a new project to take on, but you know, they.
Could I butt in for just a minute, please? Because I have to drop out of the meeting to go on another Zoom call, but I would like to thank you all for what you're doing for the AAVSO. It's good to see you sort of in person, but anyway, be well, and thanks again for all you do, and keep observing long period variables. Take care.
All right, John. Take care.
Bye.
Yeah, this is supposed to be over 20 minutes ago, but it's interesting.
Hey, I'm here as
I'll
long
be
as they're.
dropping off too.
All right, Margarita.
Thank
Take
you
care.
all. Thank you. Thank you. Thank you.
Yeah, I'll
Stay
stay on
healthy.
as long as there are people on.
Yeah.
So
Stay
I'll
healthy.
stay on for a few more minutes.
if you need to go, I understand. I ain't mad at you.
So Rich, Scott Tennell here again.
Scott. Yes, sir.
Yeah, so I kind of laid out, what I can do here. Here's the question for you. What can I do that could be the best benefit for AAVSO? What direction can you give me as saying, from myself and observers like myself, what should we be doing?
Man, that's a good question. I would say, first off, observe with whatever you have at your disposal. Work on your skill. So not just observe, but make sure that you're trying to become a better observer, and teach others. Reach out to other people you know who have abilities or have interest and have equipment, and teach that skill to them. Let
Right.
people know that it's not, it's an accessible thing. It's something that you can do, and that you're contributing, and you're adding to a legacy that's over 100 years now.
Okay, sure, got all that. Let me kind of focus my question a little bit more tightly. What types of observations that I can make would be a best benefit to the AAVSO? So what I described, what I'm doing is just picking out long period variables that appear to be in need of additional observations, particularly at the faint end. Is that a good strategy, or should I be focusing on some other some other kind of type of target or group of targets? I want to use my time effectively and not just randomly shotgun observations into the database.
I understand. So that was the theory behind the LPV program. I didn't do it. There was a paper written at JSO that kind of outlined the theory behind it, where they looked at, there's a bunch of MIRAs out there. They condense it down to MIRAs that have long observational histories so that we could have a baseline on, and that were sufficiently observed. It means a lot of people tended to observe them, so we figured continuity would persist. So continuing to add to those LPV program stars is valuable, just because we don't want to lose the fact that we have such long-term trends available on those stars. Now, the other thing I would look at, and that's where things like we discussed, the Percy list, stars that are exhibiting some kind of change, because for one thing, the MIRA or asymptotic giant branch part of their life is pretty I would say in stellar terms, pretty short. And we can actually observe some of this evolution on human timescales, whether it be decades or potentially, centuries. Well, it's enough where we can actually exhibit changes. So if something is changing, we definitely want to focus on it. That's a good place for visual observers. Again, the program stars, things that have time series like period changes. When it comes to photometry and multiband, that's when you start looking at collaboration with some of the Johns, the Leannes, Margaritas can tell you more about. These are interesting stars. We can get multiband photometry on them, and we can learn more about the physical nature of the stars. I saw your hand up earlier, Eric. Did you have more to add to that?
Yeah, I think a misconception, and it may be different from other types of observation. We really want to look at stars that have been looked at. We really want to fill gaps. In fact, my entire program was based on gap filling. People would say, well, you're observing it all the time. And I go, I'm only observing after there's been a gap of a certain number of days, a certain, I think it was 2% of the period or something. If you don't want me to hit that star, don't leave a gap. And, you know, we're all gap fillers when it comes to this. So maybe a restricted set of initial stars, Percy list would be as good a starting place as I know of. It covers north and south too, as well, by the way.
Yeah.
Make sure that we have the resources, including comp stars, really available for all of them, so people don't get in there and they're disappointed that they can't actually do it. And then work outwards from there, maybe splitting into different types of stars, different magnitude ranges, period lengths, that kind of thing. But start with a set of 50 or 100 stars that we need to cover no matter what. We need to fill the gaps no matter what. That's more than we're doing now.
Yes. No, that's a great
and
point.
that would be a big accomplishment.
Yeah, a lot of people always say, "Oh, I got to observe stars because they're never observed." I'm like, no, that's not what you want to do.
Well, I
have
did
to
that
keep...
with some stars that I would commit to for 3 or 4 years, maybe, you know, 5 periods for Myra's. But you're right. In general, that's right.
Right, and that's what the program stars are meant to do. Where these stars we don't want to lose or have those big gaps where we have long observational histories. We need to keep that going. Don't try to develop a new one. Say, oh, no one's ever really observed this, Myra, in 50 years. Let me go observe it.
But there's also that list that's published of seldom observed stars.
Is that seldom observed program stars?
I don't know. I thought it was there. I thought they were long period variables that are not observed that often. And the idea being, as was said, to sort of fill in some of those points or get some more points on those.
But
I need to look at that because something I've wanted to do is find a program similar to what Eric was talking about. These program stars haven't been, you know, it's gone too long before, you know, we need somebody to look at it.
Well, maybe we're talking about the same thing.
Yeah. So it's not something like, oh, there's been 100 observations on it in a 10-year period. That's not doing anybody any good to add 101 or 102 to that. But if it's a star that has thousands of observations over that period, you got to keep adding to it.
Okay, Scott here again. So a number of years ago, I think this has been discontinued. There was something, I think it was called Bulletin B, that was published that would contain a list of LPVs, and they would be tagged by more observations needed, observations urgently needed, et cetera, et cetera. So that seemed to have gone away, but that's what comes to my mind.
Yes, Eric and I could talk a lot about that, actually.
It didn't, yeah, the bulletin that I was associated with once AAVSO staff dropped it, what was it, Rich, 2 years ago?
Yeah.
I picked it up a year ago with software that I wrote from scratch. It's the same list of 400 and something stars. I didn't change that. I'm giving that up next month, by the way. Software is free to a good home. It's right on my GitHub page. I'm going to run it once next month. It didn't, the list I'm thinking of did not have needed or not needed. It had minimum, maxima, rising, falling for each month, so that I gather visual observers or small scope observers would have a constant list and know when to observe based on their equipment or preferences. Is that the same list, Rich?
There was one on the website. I think it came from Bulletin Generator, which was discontinued with the other one, where if you ran it, you could say, give me the program stars in, like, you know, Cassiopeia. It would give you a list, and it would tell you how many observations were made in the last month. And it would give you the rising, falling, maximum. So
now, that wasn't a bulletin. That web page is still there if you know where to find it.
Yeah, I know, because I went and ran, I'm like, Because I
far
use
as
that a lot, and then they stop making the bulletin, and people are probably still running it, and not realizing that it's for 2018.
Yeah, there is the software on my computer, LPV predictions, and I've used that to find out, you know, maxima and minima and on stars and when it's going to be. I use that a lot. Yeah.
But it is probably something I wanted to look into, and I haven't really. If you take the program stars and just do a quick, like how many observations have been made in the month or something like that, to kind of steer people to maybe program stars that need to be hit.
I think you need to start with a list of stars that need to be covered no matter what, and maybe an aura of another 100 stars outside of that that are our ambition opportunities. And
so some
if you could do that, that would be more stars than we could cover, but not an infinite number where nobody knows how to get started. Gives you something to point to.
Yeah, so kind of maybe rank, like if you took the program and find a way to say, these are the most important to go out based on some parameters right now because of lack of observations. Then here's the next, you know, if you gave them a rating system like A, B, C, and D, and A is most important, B is your secondaries.
In fact, that's exactly how I have my scheduling program structured. I have a 1, 2, 3 priority rating for each object, and then in addition, I have a separate must observe 0, 1, you know, Boolean, so that if there's some object that just, you know, I've got to observe every possible opportunity, I'll set that flag to must observe. Otherwise, the scheduler deconflicts based on priority and date last observed.
I need to give Bert some more stuff to do. So if we took Eric's code, have him hosted on the new website, and then
no, I've covered that with Bert.
Oh, come on.
That is not a high enough priority for them right now, or at least it wasn't as of 6 months ago when I asked. I asked, do we want to host something on a web page based on my Python engine that took over the bulletin so that people can put in requests and get a short list of 8, 10, 20, whatever they want, stars that most match what they want. I got giant raspberry on that one. It's not going to happen this
Yeah,
year.
I got to work on them then and use my sales skills, because that was,
go with a coherent proposal. And Jay, I mean, others.
Let's see.
It's
I
not
need
a
to
bad
go in there
idea.
with a bat. I was going to look for a baseball bat. That would be my coherent.
Yeah, I think I tried that route, so I got nowhere. So maybe you want to try the coherent proposal of a modest pilot size that could be expanded later. I think I was catching them in the middle of all the server security problems.
Yeah, and I'm thinking when they get the website back up and running, he may be more receptive to taking on some of these and building out a module, because that was a very useful tool. And I've brought that up a lot of times, was that bulletin generator. I used it every single time before I went out. I do the same thing now. Now I go to VSX, I have to do more steps because I'll get some targets in the area of sky I want to see. Then I go I start doing more research to whittle that down. It's more time consuming, but it was beautiful when I could just go in and say, I want to look at this section of the sky, give me stuff in these, this brightness range, and boom, I had a list. I could go out.
Okay, I'm gonna have to leave, so I'll see you guys. It was very interesting. Glad I joined this. See you all.
We had Philip join us. At one point, we went all around, and everyone was given a quick detail of some of their interest and what they're looking for the LVV section. So, Philip, I'll hand it off to you if you wanted to jump in and talk about some of your interest besides discovering new variables. Oh, maybe not. So, what else? Anybody else have any anything out there that they wanted to discuss, or ideas or things they would like to see, improvements that we can make?
I need to take off too. I have an important Zoom conference with a 4 and a 6-year-old.
Ah, yes.
I'm going to have my tea. Yeah. Nice
Yeah.
talking to you all. It's been very interesting.
All right, everybody. Sounds like we're about to bow out. So
Yeah.
I think we're breaking.
catch y'all
up. Yeah,
later.
thank you very much.
Don't
Really
know how to get a
appreciate
hold
it.
of me.
Yeah. Thanks very much.
Thanks for hosting this, Rich.
Yep. Appreciate it.
Goodbye. Thank you.
All right. Bye.